Okay, so to do 10.3 number 37, I think we have to read what they're saying and carefully write it down. No? We shouldn't read what they're saying? We should just guess? 6.5.
Nailed it, actually.
I thought you didn't like improper fraction.
6.5.
Cool.
All right, next
No?
one.
Next problem.
10.3.
C. All right, let's try actually reading. So it says an average of 50,000 people visit Riverside Park every day in the summer. So 50,000 people per day. Well, maybe at least on average, right? And then it says the park charges 15 bucks. Damn, dude, 15 bucks for a park? Come on. Okay, and consultants predicted for each dollar increase, the park will lose an average of 2,500 customers. Okay, $1 up is the same thing as 2,500 people down per day. Right? Okay, then it wants me to express the daily revenue from ticket sales as a function of the number of $1 increases. Get all with that? Okay, so I think I want something like revenue as a function of increases.
Revenue, so it's going to be dollar amount?
Yeah, so revenue should be a dollar amount, right? So I need to think dollars. Well, per day, I guess.
Okay.
So to get dollars per day out of people per day and presumably dollars per person, how am I going to do this?
All right, we start out with 50,000 people a day. Multiply by 15 people, $15 per person.
Okay, I think that's a good starting strategy, right? So like revenue is basically going to be dollars per person times number of people.
Yeah.
Right, like the easiest answer is if you don't increase the ticket price at all, this is 15 times 50,000.
And then you.
So if I make some increases, right? If I increase my ticket price by I dollars, what is the ticket price going to be?
$16.
That's if I did it by $1.
Isn't that what you just? I missed.
By I dollars.
Oh, by I dollars.
15 plus 1
Okay. So in here, right, in your ticket cost, you're going to do 15 plus I.
Yeah.
Because that's how much a new ticket's going to cost.
Yeah.
If I is 1, you're getting 16 bucks.
Oh.
If I is 2, you're getting 17 bucks. If I is 25, you're getting 40.
And then you multiply it by the 50,000.
And then I need to multiply by 50,000.
Minus 12,500 I.
Yeah.
Oh, and then, right, it's not 50,000 anymore because you raised the ticket.
Yeah.
So you're going to lose how much?
I,
12,
12,500.
well, it says 25.
2,500 times I.
Yeah.
Oh, that's a down arrow. It looked like 12,500.
Perfect.
Perfect. Even more perfect, which kind of defeats the definition of perfect.
Okay, so at any rate, I have this thing. Now, what do they actually want to know?
What ticket price maximizes the revenue in ticket sales?
Oh, so you want to find the point at which it changes.
Yeah. So,
Profit.
you guys want a trick?
So you
Is it a trick of the trade?
Kind of.
Then yes.
Okay, what category of function is this?
What
category of
a linear?
Yeah, what kind of function is that? Is it a line? Is it a
it's a
sine curve? Is it an
It's,
exponential?
Parabola?
Ah, hey. Why is it a parabola?
Because it has two eyes. Eyes.
There are two eyes and they'll be multiplied together when you FOIL this crap out, right? So if you FOIL this out, you'd get an I squared term from these guys. From this guy and that guy, you'd get I terms. And from these two, you'd get a number.
Yeah.
That's like a AI squared plus BI plus C.
Yeah.
Right? So that's a quadratic, hence a
Yeah.
parabola.
Yeah.
Okay. So if you didn't notice this, what would you do?
You'd multiply.
Yeah, you could FOIL it out and then maybe you'd notice. If you still didn't notice that it was a parabola,
Oh, if you just missed it.
then you maybe slam this in a graphing calculator and see what it looks like. The trick I wanted to highlight is that a parabola has a top here, right? That's the maximum I'm looking for. How do I know this parabola's upside down?
Because it's negative 250,000.
Yeah, because there's a negative 250,000 times a positive I, right?
Yeah.
Okay, so I know that there was a vertical flip that happened in that parabola,
Yeah.
right? So I know it's pointed down. And now what I'm really interested in is where is that top value?
It's when x is 0. No, I don't know. Well, that's the question.
Yeah, that's it.
It's the maximum, right? So the trick to go about finding that is to figure out if there are two zeros, it's going to be halfway in between,
Right.
right? So what are your two spots where you could have no revenue?
Oh, so, right.
Okay. So this part here, right, if you lowered the ticket, or, well, in this case, if you raised the ticket prices by negative 15 increments of $1, you would just give money away, or you would give tickets away, right? And you would have no revenue. You guys see that?
Yes.
Okay, so at negative 15 I have a 0. Over here,
20.
yeah, if I increase ticket prices to $35, no one will pay that to come to my park.
Yeah.
So, my intercepts,
Oh.
right, this is really R of negative 15 is 0, and this is R of 20 is 0. Right, you make no revenue at those two values.
So in between there.
So they're 35 units apart, right?
2.5.
Right, so like from here to there is 35 units. That's negative 15, that's 20.
20 minus 17.5 is 2.5.
Yes. You want halfway in between, right? Because these are the spots where you're breaking even, or where you're not generating any revenue at all.
Right.
To get your maximum, you need to be halfway in between.
Yes.
That only works when you're dealing with a parabola.
Fair.
But halfway in between there is 17.5 units from each side, which is at 2.5.
Which is $17.5.
Which makes your ticket,
17.5.
which you should phrase as,
Halfway between negative 15 and 20.
oh wait, how did they actually ask this? What ticket price maximizes revenue? $1,750 per person maximizes revenue.
But negative 15 plus 17.5 is 2.5.
Right, same time. Parts online.
Right.
Yeah.
You're at
You guys cool with that?
Yes.
If you have not had a math class from me before, you need to remember that when you answer a word problem, you should do that like a person. Right? Don't circle 17.5. Right? They asked you a sentence about something, answer
In a sense.
in a sentence about that same thing, preferably. Cool? Like, I'm not expecting Chaucer here, but like a subject and a verb and the number that you wanted to include should be in that sentence. Right? Ready with me?
Yeah.
Subject, verb, answer.
Yeah.
Those are your minimum included things. A little context, yeah, a complete sentence. It would be really rad if the subject and the verb agreed, but I'm willing to let some of that go.